after looking at functions of two variables, it's natural to think if we can extend them in our discussion at least to talk about the calculus of functions of multiple variables. So if we go all the way back to introductory calculus, you'll recall that the limit of a function as it approaches a point is equal to some number if the function value approaches that number as the input approaches that particular input value. So we say that that's the limit. But what about the case where we're doing a limit with multiple variables? So x, y, not only x doesn't just approach a, but y approaches b. And so we'll come back to this in a moment. If you remember from standard calculus, you had x. It could approach from the left or it could approach from the right. And you just sort of traveled the path of the function output, and it was bounded. If the limit existed, these values would come closer and closer, and boom, you hit the value. But in multiple dimensions, this is problematic because you're not really just riding a single line anymore to a point. You have an entire surface. So if I'm trying to approach this point from a function value standpoint, I could have all of these values, or I could approach it across the surface with some sort of hook pattern, or even like a sine wave. So there's any number of ways to approach a point. It's no longer you're just coming from the left or the right. You could be coming directly down on top of it. You could be coming from the sides. You could be coming in, actually you can go with like concentric circles. There's so many ways that you can approach a point. So to solve limits in multiple dimensions requires a little more ingenuity. As such, there's a three-step pattern. It doesn't always work out to do it this way. But the first one is just to try plugging in the value. If you can plug the value into the function and it exists there, you have a pretty good belief that that's going to work out just fine. There are reasons maybe not to think that if it's like piecewise defined, but in general, plugging in is always your first choice. The second one is what's going to be called parameterized path, and we'll discuss what that means in a little bit, but really the idea is think of a line that's going into it, but you're varying the slope on the line. So you're still going through the point, but you're going maybe at different angles. And the final one, and this is kind of cheeky, but it's be clever. And the reason why is because there are a lot of tricks and things using algebra and estimation that make solving these limits pretty much the only way you can do it is to be clever about it. But for practical purposes, if we focus on these first two, we can cover a lot of our bases. Notice that plugging in checks for existence. Parameterized paths, usually you're checking to see if it doesn't work in this way. So we'll do some examples and see if we can get a better understanding of how to approach limits in multiple dimensions.